In our last video, we looked at equations of lines using the point-slope form, and we also looked at the equation of a horizontal line. Remember, horizontal lines are of the form y equals a number. So we want to move on to vertical lines. Vertical lines are very special. So remember when we talked about slopes that are undefined, that gives you a vertical line. That was way back when we looked at slopes. So we got a fact here. Fact. It says the following. A line L passing through a point let's call this point x1, y1. So you know a point on the line with an undefined slope That means it's vertical, right? Vertical line. If you got an undefined slope, you got a vertical line. Has equation. Well, remember when you had a horizontal line, it was of the form y equals a number. A vertical line is just going to be x equals a number. Has equation x equals what number? Well, it's going to be the x coordinate of the point that your line passes through. So x equals x1 will be the equation of your vertical line, or when you have an undefined slope. Pretty cool. So actually, vertical lines are easy. Let's do an example. Fine. So exercise. Haha, spelled wrong. Find the equation of the line L. Capital L. So here's number one. Description of L. L passes through the point let's call the point -7, 5, and has undefined slope. Has an undefined slope. So immediately when you hear undefined slope, you know this is a vertical line right here. Vertical line. And as soon as you hear vertical line, you know that the equation is going to be x equals a number. What number? Well, if you go back and look at your point here, -7, 5, x1 is -7, y1 is 5. It's going to be the -7. X equals -7. So there you have it. If you wanted to graph this, which I'm not asking you to do, but let's just graph it for fun. What you're going to do? You're going to do a y-axis, you're going to do an x-axis, you're going to find 1, 2, 3, 4, 5, 6, 7 negative on the x, and you just draw a line straight up and down. Straight up and down there, going through the x coordinate of -7. Now let's actually think about that in terms of a XY table, a table of values, right? We can think about it in that context. If I did a table of values, X column and a Y column, I could put -7 in for X always. 1, -7, -7, -7, -7. And it doesn't matter what y is, right? We just know that x is always negative 7. Y can be anything. You can put like negative 2, negative 1, 0, 1, and 2, and for y. Yeah, so let's think about those. Negative 7, negative 2 would be here, negative 7, negative 1 would be here, negative 7, 0 would be here, negative 7, 1 would be here, negative 7, 2 would be here, right? So all those points that I just plotted from the table of values, they show up. They show up. Okay, so that's a vertical line, a line with undefined slope. They're special. They're always of the form x equals a number. Very important. We're going to do another exercise. This one is not going to be about vertical lines. This is going to be, let's say you got 2 points. 2 points. And you want to find the equation of the line going through 2 points. So here's the description of the line. So find the equation of the line L. L passes through 2 points. Let's say the first point is, how about negative 3, 8? And the second point, I'll call it Q. Let's make that maybe negative 1. How about minus 4? So there we go. We got our 2 points. Negative 3, 8, negative 1, negative 4. So how can I find the equation of a line between 2 points? Well, the first thing you can do is find the slope of that line. Find the slope. So we're going to find the slope first. So the formula for slope is m equals y2 minus y1 divided by x2 minus x1. So my points here are x1, y1, that's my p, and x2, y2, that's my q. I'm going to plug in appropriately. Let's make a template. M equals blank minus blank over blank minus blank. In place of the y2, I'm going to put a negative 4. In place of the y1, I'm going to put an 8. In place of the x2, I'm going to put a negative 1. And in place of the, which one? x1, I'm going to put a minus 3. Now, look at that double negative down there in the bottom. All right, we got a double negative. We have a negative 1 minus negative 3. The double negative makes a plus. So in reality, what do we have? We have m equals negative 4 minus 8 is negative 12 over negative 1 plus 3. Negative 1 plus 3 is 2. That's going to give us a slope of, well, negative 12 divided by 2 is negative 6. So we get a slope, right? We get a slope. So you have a slope, and you got a point. Actually, you have 2 points. You have 2 points. So you can use the point-slope form when you have a point and a slope. Point-slope form. So that's what I'm going to do next. I'm going to go, let's go a little green for that. Point-slope form. Equation. Remember for that, the formula is y minus y1 equals m times x minus x1. So I got a point of negative 3, 8 that I'm going to use right here. Be nice if this worked. I'm going to use this for my x1, y1 in my point-slope form. Now, can you use x2, y2? Yeah, you can actually use the x2, y2 if you want rather than x1, y1, but I'm going to use x1, y1 in my point-slope form. And for my slope, I got negative 6. Okay. So here we go. We have y minus y1. What was y1? y1 was 8. Equals m we just calculated was negative 6, and then multiplied by x minus x1. What was x1? It was minus 3. So I plugged in -3 for x1, 8 for y1, and -6 for m. Now we can simplify this. We want to simplify. So notice that you get the double negative in parentheses. The double negative is going to give you a plus. So in reality, what do we have? In reality, it looks like we have y minus 8 equals, let's distribute this -6. We're going to have -6x. And then -6 times -3 is -18. And that's going to give us an equation of y minus 8 equals -6x minus 18. I'm going to add 8 to both sides. Add 8 to both sides. And when we add 8 to both sides, we get y by itself equals -6x minus 10. So here's the equational line going through those 2 points.